Minus 25. Minus 20. Minus 15. T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, fire.
We have ignition of NASA's Space Launch System 5-segment solid rocket booster.
Plus 10. Plus 20. Plus 30. Plus 40. Plus 50. T plus 60 seconds. Plus 70. Plus 80.
Central Support Systems Operator, enable the deluge, CO2, and quench tool controls.
Controls are enabled. Plus 90.
Open the accumulator enable valve.
Accumulator enabled. Plus 100. Plus 105.
Activate aft deluge.
Aft deluge activated. Plus 110.
Activate forward deluge.
Forward deluge activated. T plus 120.
Activate head end CO2.
CO2 activated.
Activate quench tool command forward and aft CO2.
Activated. T plus 165 seconds. High-speed data operator stop recording.
The full 2-minute test has concluded.
High-speed recording.
Now
is
the
complete.
carbon dioxide
Roger.
quench
High-speed
arm pumps
operator
31 tons of CO2 into the booster. The carbon dioxide quenches any burning of the insulation without damaging it to preserve the state it was in during the test. This allows the team to get the best data about how it will perform in flight. There's quite a bit of action remaining for the teams here as they ensure the test area is safe and the data are recorded. Following motor burnout, the chamber will be sprayed with 2,300 gallons of water per minute on the underside of the case to help cool it down. This will cool the chamber from 1,000 degrees Fahrenheit to 300 degrees Fahrenheit.
Avionics engineer, verify that the Celestic has finished saving the log files.
In work.
Roger. Redline monitor operator, transfer the log file to the local computer.
Roger, in work.
Roger. Bus monitor operator, transfer the data files to the local computer.
In work.
T plus 4 minutes.
Redline monitor files have been transferred to the computer.
Roger.
Let's go back out to Bill, where he's standing by for first reactions from those who were outside watching the test.
Thanks very much, Stephanie. Yeah, 2 minutes of excitement and exhilaration, followed by jubilation from the crowd, as well as some of the gentlemen who helped make this happen. I'm joined by Alex Priscos. He is the SLS booster manager at the Marshall Space Flight Center, and of course, rejoined by Orbital ATK's Charlie Precourt. Charlie, let me start with you. Everything seemed to go well, and how do you think it looked?
It looked really clean. We're very excited. It's a great result. You could feel the pressure coming off the motor. You could see the plume and watch the vectoring. It all looked great. We'll be looking for the quick look data, but really nice result.
I think what was exciting, and I haven't been to one of these in a couple of years, so it was really exciting to see is you've got that initial pause when everything loads, you see all the smoke and the fire, and then suddenly that sound wave hits you.
Great little science demonstration for the speed of light, the speed of sound, you know, the little delay, and then the noise hits you. Really pretty neat.
I know that you and your crew are far from finished. What do you immediately is your crew doing up there right now?
So we're making sure all the systems are shut down. You know, we had hydraulic power units running and so forth. All of that post-fire stuff begins. We got quenching going on. There's a lot of water systems up there cooling the belly of the booster because a lot of the residual materials in there that are so hot, that plume was 5,000 degrees. A lot of that hot stuff is laying in the belly of the booster, so we got cooling water jets cooling off the belly of the booster so that it doesn't get too hot. And then over time, we'll be able to go up and take a look, and the dissection will begin, and all the data will start to flow, and we'll be looking for qualification.
And if I'm not mistaken, a lot of that hardware can be reused, right?
Absolutely. All of this stuff will get recycled and used in either another test or maybe in flight.
Thanks very much, Charlie. Let me turn now to Alex Priscos, once again with the SLS program out of the Marshall Space Flight Center. You look like a happy man.
I am very happy this morning. Great test. Just a fantastic result. You used a stopwatch. We haven't seen the real preliminary data, but we get a little bit with just a watch, and this thing was about as perfect and nominal as it could be. We were looking for a 2-minute firing time, and that's what we got. So it's great. I'd like to thank Orbital ATK and the NASA team for all they've done to get us here. It's been just a fantastic effort on everybody's part.
So let me ask you, I know you've got a lot of your team here as well as you met some of the folks from Orbital ATK as well as some of our NASA social media visitors. What has been some of the reaction from some of them about being here and then seeing something like that? I saw lots of handshaking on your way up here.
You know, the enthusiasm that you get in a test like this is just incredible. It shows what these kind of tests mean to everybody that literally spend years and years and hours and hours and hours every week working on it, as well as those that just show an extreme amount of interest. And to watch the momentum and the interest build in this program has absolutely been fantastic, and it has really, really built consistently the last several months.
So what's next for the booster team in the short term?
So in the short term, we'll look at this data. We'll look at it on several levels. We'll get our first pre-look at the data in probably about an hour, but we'll continue to dissect and go deeper and deeper into data for several months. Meanwhile, we will be preparing qualification motor number 2, which is our second qual test, which will be a cold test to understand the performance in a cold condition. And that will probably happen early next year.
So what are some of the finer points of the data that you're going to be looking for?
Pressure time curve, which really gives us a sense of power and when it happens and how much. We'll be looking at the erosion of the insulator, which tells us how much margin we have thermally in the system. And we'll be looking at nozzle erosion. Those are just 3. There's several hundred parameters, but those are the 3 that we'll be looking at very, very hard and very quickly.
All right, excellent. Well, thanks once again very much to the both of you. Congratulations on a successful test, and I know a lot of us, I speak for many of us out here who are just glad we could have been here to be a part of it. Once again, Charlie Precourt with Orbital ATK, Alex Priscos from the SLS Booster Program. So, gentlemen, we're going to take, before we head back inside to Stephanie for a few last words, let's take a look at some of the replays of the test we just saw.
We have ignition of NASA's Space Launch System 5-segment solid rocket booster.
Support systems operator, enable the deluge, CO2, and quench tool controls.
Controls are enabled. Plus 90.
Open the accumulator enable valve.
Accumulator enabled. Plus 100. 1. Fire.
We have ignition of NASA's Space Launch System 5-segment solid rocket booster.
Plus 10. Plus 20. Plus 30.
We have ignition of NASA's Space Launch System 5-segment solid rocket booster.